Today we are looking at the probability of a single event occurring. So we will be looking at probability of multiple events, but today, right now, we are only looking at probability of single events. So we first need to define what probability is. So the definition of probability is used to measure the chance of an event occurring. A desired outcome is called a success, but anything other than success is called a failure. Okay, so the desired outcome is called a success, anything else is called a failure. So we do have a identity for probability. The probability, or P, of a specific outcome, so we will list the outcome inside of those parentheses. Probability of the outcome is equal to the successful outcome, so what we want to happen, over all other possible outcomes. Okay? And probability does have 5 rules to it, so we need to make sure that we look at those as well. The probability of an event must be between 0 and 1. So 0 is less than or equal to the probability of an event occurring, which is less than or equal to 1. So we should never get a negative probability, and we should never get anything greater than 1. If you are ever looking at the probability of an impossible event occurring, that answer will always be 0 because it can't occur at all. Or if you are looking for the probability of a certain event, which means there's only one possible outcome, the probability will obviously be 1. Because all probability is greater than 0 but less than 1, the sum of all probabilities for all possible outcomes will all add up to be 1. We also have what is called the complement of the probability of an event happening. So the probability of the complement will be 1 minus the probability of the certain event. So all probabilities will add up to 1, but if we're looking just for the complement of a certain event, we can take that 1 and subtract the probability of the certain event. So let's actually look at a couple of examples first. For example 1, we are going to be using the situation that a die, which means just one dice, is rolled, and we want to find all of these probabilities. Now remember, a dice or a die has 6 sides to it, all numbered 1 through 6. Okay? So the probability of rolling a 5, there's only one option or one way to roll a 5. So the probability will be 1 over all possible outcomes. There are 6 sides to the die, so the probability of rolling a 5 is 1 over 6. Okay. The probability, part B, of getting a number less than 3, there are two different ways to roll a number less than 3. You can either roll a 1 or a 2. So that means the probability of rolling less than 3 is 2. The 2 possible outcomes over all possible outcomes, which is 6. So the probability of rolling a number less than 3 is 2 out over 6, but we can reduce that to 1 over 3. So the probability of rolling a number less than 3 is 1/3. C, the probability of rolling a number less than 13, well, there are only 6 sides to a die, so any number that you roll will be less than 13, so the number of possible outcomes is 6 over 6, which is equal to 1. So this is what we would call the probability of a certain event. It's always going to happen no matter what. Certain meaning it is for certain, will always happen. D, the probability of getting a number greater than 6. A die only has numbers 1 through 6, so you will never get a number greater than 6. So there are 0 successful outcomes out of the 6, which gives us a probability of 0. So this is what we call an impossible event. Okay, letter E, we are looking for the complement of getting a 5. So we want to take 1 minus the probability of rolling a 5. Now we did the probability of rolling a 5 in part A, that's 1/6. So we want 1 minus 1/6. So we need to get common denominators here. We can put the whole thing over 1, multiply top and bottom by 6, and that's going to give me 6 over 6 minus 1 over 6, so the complement of rolling a 5 is anything but rolling a 5. So you have a 5 in 6 chance of rolling anything but a 5. Example number 2, our situation is that one card is drawn from an ordinary deck of cards. Find these probabilities. Now remember, an ordinary deck of cards has 52 cards in it. So part A, our probability of getting a jack. Now there is 4 suits in a deck of cards, so that means for 1 jack for each suit. So there are 4 jacks in the entire deck, so the number of successful outcomes would be 4 over 52. And we can actually reduce that. 4 goes into 4 once, and 4 goes into 52 13 times. So our probability of getting a jack is 1 over 13. Part B, the probability of getting a 6 of clubs. There's only 1 6 of clubs in an entire deck, so there's only 1 successful outcome there out of the 52 possibilities. So the probability is 1 over 52. The probability of getting a diamond. So we can pick any card as long as it is a diamond. So we have the numbers 1 through 10. Then we also, or the numbers 2 through 10, I'm sorry. An ace, so that gives us 10 cards. A queen, which is 11. So we have 2 through 10. The ace. Queen, which gives us 11. Jack, which gives us 12. And the king, which gives us 13. So there are 13 ways that we can get a diamond out of 52. And that reduces. 13 goes into 13 once, and 13 goes into 52 4 times. So the probability of getting a diamond is 1/4, which makes sense because there are only 4 suits. So we have a 1 in 4 chance of getting a diamond. Part D, the probability of getting a black card. Half of the cards are red and half of the cards are black. So our probability, there are 26 black cards out of 52 total cards. So that gives us a probability of 1/2. Okay, example 3, we have a bag that contains 6 white, 3 blue, and 7 green marbles. 1 marble is chosen at random. What is the probability of each event? So if we have 6 white, 3 blue, and 7 green, that means we have 16 total marbles. So that is going to end up being our total possibilities here. So we're first looking for the probability that the marble is white. Now we only have 6 white marbles, so the probability is 6 out of the 16 total. And 6 and 16 both reduce by 2. 2 goes into 6 3 times, and 2 goes into 16 8 times. So you have a 3 out of 8 chance of pulling out a white marble. Okay, the probability that the marble is not green. So there are 7 green marbles. We only want a white or a blue marble, so that gives me 6 plus 3, which is 9. So the probability is 9 out of 16, which does not reduce at all, so that is your answer. Part C, you are looking for the probability that the marble is blue or green. So we need to find the probability of the marble being either green or blue. The probability of drawing a blue marble is 3 out of 16, plus the probability of drawing a green marble, which is 7 out of 16. So that gives me a total of 10 out of 16, which reduces by 2 to 5 over 8. So that is the probability of a single event occurring. Remember, we can find the probability of a single event occurring by taking the number of what would be considered successful outcomes and turning it into a ratio over the number of all possible outcomes. So this is another formula identity that we need to know regarding probability.